Okay, hi everybody. I'm Benjamin Kovach, and I'm here with Matt Parsons, and we're going to basically just be doing a Haskell workshop for you today. I assume that's why you're all here. The way that we're going to do this is Matt's going to take over in a minute, and he's going to kind of talk through some of the syntactic stuff and just kind of how Haskell looks and just to get an idea of what we're getting ourselves into, and so we don't get lost in the implementation of what we're going to actually write together. And later on, we're going to build a simple dynamic website that just hits reddit.com, and it'll aggregate your favorite subreddits into a single page. And we'll do that in a little bit after we get started here. But without further ado, go ahead and take over. We'll turn on the screen share here and get started.
Super tunnel, this is my favorite.
All right, there we go. All right.
Cool. Okay, so first things first. Did everyone get the email for like downloading Stack and installing it and cloning the GitHub repository? Okay. Okay. Yeah. If you go to it's Stellar Labs / Haskell-workshop. Okay. The README, I think, has all the instructions for getting it set up. So if you need to, then you can just clone that and follow it. So this, if you've cloned the repository, this file that I'm working with right here is in the source directory, and it's just syntax.hs. And this is kind of a like through of Haskell syntax. And so the first thing is that Haskell is like very weird and different from what you're used to. But one thing that I hope to impress is that while it is weird and different, it's not any less weird or different than regular programming is. It is because we've gotten so used to it. Yeah?
Does everybody have Wi-Fi access?
No. Oh, okay.
Yeah, Haskell
Okay, Wi-Fi, we do need that.
Yeah. What's the... It's up there. Oh, it's up here.
Sure.
Wireless info's here. You guys just want to pass this.
I'll try this, by the way.
I'm not sure.
Round sphere guest.
1979?
Yeah.
Okay, sorry.
Supposed to hang out for you.
Yeah. What hangout are you in?
I do not know. Unfortunately.
Can you also go to the GitHub link?
Yeah.
/Haskell. What's the hangout link? What's the hangout? I go to the link in Slack. Okay.
Okay, cool.
Oh, okay. Yeah, okay. Where to that?
Okay, so everyone's solid on the GitHub and the Wi-Fi's and the other technological bits? Okay, not seeing any objections, so we're going to go on. If you need this username or password again for any reason, let me know and I can scroll back up to it. So the first thing with Haskell syntax is that these two hyphens, they're a line comment. And then if you want a block comment, like the /* and like the C-based languages, you use the open brace and then a hyphen. And then you can get block comments with that. And these are actually nested, so I've never seen a reason to do that, but if you wanted to, you can have nested comments like that. So the first thing that we do with the syntax, or we do with the Haskell, is we declare our module. And so what this does is this declares that we have a module named syntax. And what's following is going to be a list of declarations. So where in C or Ruby or other languages, what you have is a list of statements that like tell the compiler to do things. What you're telling Haskell here, instead of like do this, do that, do that, you're saying here is a list of things, and this is what things are going to be equal to. So we're defining declarations of what things are rather than telling the computer what to do. So this is our first example of a data declaration. And data is how we create new types and new data constructors for those types. It's similar to a struct in C or classes in object-oriented languages. If you pretended that all of the class's members were final and immutable and it didn't have any methods attached to it. So we use the keyword data to introduce a data declaration. And then everything up to the equal sign is the type name, or the name of the type of a thing that we're building. And the stuff to the left is the very first thing we have right there. That is a data constructor. And so that's kind of like what you might use in like a new function in Ruby or an OO language. You would say new person A, and then you would pass the string parameter as the first one, and then an int parameter as the second one. And we can read this in English. We can say that we're creating a new data type, and the name of the type is person A. And person A has a single constructor called also person A. And it takes two parameters. The first parameter is going to be of type string, and the second parameter is of type int. And this is actually kind of a common thing for people to get stuck on at first, is that this person A right here refers to a type name. And this person A right here is a constructor name. And so this is a value. It's not a type. But this back here is a type. And so Haskell has two namespaces, one for values and one for types. Concrete types always start with a capital letter like that. And data constructors also are functions that start with a capital letter. So everyone pretty good on that?
Are they
That's mostly a matter of convention. They don't have to be. And it's actually somewhat common to see someone like, I'll just make person if you want, but they can be the same thing. And it's often helpful if you just have like one data constructor for the type to name it the same thing as the type name so that you don't have to go looking up what the type name or what the data constructor is. Oh God, what did I do? Okay. It's a space max and I have no idea how it works. Cool. So one thing that Haskell has that a lot of languages don't is this notion of like an OR type. And what this type here represents is that if we have this data type, which is named person B, we have two constructors for it. The first constructor is named adult, and it takes a string and an int. And this pipe means that we have another data constructor that we can use to construct something of person B type, and that's child, and it just takes a string. What happened? Okay. So this is kind of like a union in C-based languages, but it's a little different. It's really nice to be able to say, like, I have something that's either this or that. And it's kind of a way of simulating dynamic typing in a strong type setting. So is everyone pretty cool with like reading? This is a new data type. The type name is person B. It has two constructors. One is adult that takes a string and an int, and the other is child, which just takes a string. Right, and so in a lot of languages, you have like this object class. An object has a couple of methods built into it, usually like string or like converting it to a string. In Java, you can make everything has hash code built into it. You can compare equality for everything. Haskell doesn't give you that. In Haskell, if you want to opt into these sorts of types, the easiest way to do is to derive them after the thing. And so eq is a way to compare equality of two things that are of the same type. And OR is a way to compare two things of the same type. And show is a way to convert things into strings for like debugging purposes. And that gets into type classes, which is a little more advanced than I want to get into right now. But if you want to be able to like compare something for equality, and you can do it. And we also in Haskell have a way of doing what's called record syntax. And what this does is this is pretty much exactly equivalent to the stuff above, but we're generating these functions. So person name right here is a function that takes a person and then it returns the string corresponding with the person's name. And so when you see that record syntax, that's really all that's going on there. Okay, so generics are actually like really, really easy and lightweight to do in Haskell. This is the maybe data type, which is what we use in Haskell to simulate null in other languages. What's up?
What are the single quotes?
Oh, they're legal identifier characters in Haskell, and they're often read as prime. But this type maybe actually exists in the standard library. So in order to not clash with that name, I just put a little apostrophe at the end of it. So when we want to have a generic type, all we have to do is in the data constructor or in the type constructor, mention the type. So in here we have it's a lowercase type variable of A, and we've got two constructors, and the first is just A, and so that's a constructor that takes one argument, and that argument is a value of type A that we specified in the type constructor. And the second thing is nothing, which doesn't take any arguments, and it's just a thing that sits there and exists. So how does everyone feel about this syntax? Does anyone want to give a try reading the type or the data declaration right there in like a more plain English? No one?
Can you talk more about the concept?
Yeah, of maybe?
Yeah.
Okay, so you know in Java you have null, and every object can have, if you have.
I can't see my head right now.
Can't either, sorry. So like in Java, if you have like an object of some type, you can have, there are two possible kinds of values that can be in that type. And the first is like regular real values of that type. And the second is null. So null can be in anything. And if you try to call a method on null, or you pass null in as a parameter to a function that's expecting a real object, you get a lot of errors. And this has been referred to as like the $1 billion problem by the person that invented the concept of null. So Haskell answers that by saying that no value can be null. And instead, if you want to signify that like this method may not return anything meaningful, like if you're doing a lookup in a list or an action that can fail, you just say that you have like, it returns a maybe of that thing. And so then we have this constructor nothing, which isn't of type like integer. It's a type maybe integer. And so if something returns nothing, then you have to handle that case. And you're kind of enforced at the type level to ensure that you don't treat like a maybe integer as just a plain old integer and try to do something with something that doesn't exist, and then your system blows up at runtime. Does that answer? Okay, cool.
You might want to give an example. Oh, that's the first time we're seeing like a type parameter.
Oh yeah, for sure. So one of the things that I see fairly frequently is like if you have a dictionary and you want to call get on that dictionary with some key. And that key, like maybe it does not exist in the dictionary. In most languages, they're going to either throw an exception, and I think Python throws like a key error, and then Ruby will just return nil, or throw an error depending on which method you use. But in Haskell, what you would write is you would say like, you would have a function, and it would say, you would have a map of keys to values. And so that's what the type of that function would look like. Here we have a map of keys to values, and we take another value that's of type key, and then we return something that's maybe the value. So if the key doesn't exist in the map, we can just return nothing. If the key does exist in the map, then we can return a data constructor that just has value in it. So does this make like good sense about how to like read what this type is? Okay. So this is just like a little brief introduction to how we can create generic types. And this right here, this is a definition of a singly linked list data type. We use these a lot in Haskell. They're really common in functional programming because they're so simple and recursively defined. It's very appealing to us for some reason. So this is another way of laying it out that kind of makes it a little more clear that we're talking about something that can be like one or two things by laying the cases out side by side like that. We've got a data declaration, and just to read this in English, we've got the name of the type is list, and it takes a single type parameter, which we're just going to refer to as a lowercase a. And it's got two constructors. The first is cons, which takes a value of type a and a value of type list of a. And the other constructor we have is nil, which just is the empty end of list constructor.
The 3 A's unrelated.
The 3 A's are all the same. They all refer to the same A type that's right here. So we actually can use like as many types as we want to. And those, we can use those however we want to in the declaration.
So if you said list A, cons B, list C, that's something different.
Yes. Yeah. You
Okay,
have
so
to,
this is the same A.
yeah.
Right, yes.
You can kind of read it like almost like a function that takes an A. And then that A is we're using the body of the function, which in this case is that.
You're putting an A on front of the list. That's the list.
Yeah.
And that's an A. The list of A's. Oh, dude, that's the time. Yeah, yeah, okay, got it. Right, because they're all the same, so it's like a list of A's. Right, I got it.
That's it.
Yes, in Java, this is what that would look like. And also, like, if anyone's more comfortable with like seeing these syntax in another language, I could be glad to provide it in a language of your choice if I know it. So this is like basically the same sort of thing. In Java, we've got these two functions we're creating, and cons just returns a value con in front of the list, and it takes the rest of the list. So, yes?
So list A, cons A, list A, and then there's the or nil. What is the nil? I thought it was like no nil.
Right, so this is a special constructor that we're using to signify the end of the list. It is baked into the type of list A. So if we have a value of type nil, we know that that value has to be a type list of A for some list of A. And when we get into pattern matching on stuff, we'll also see that the compiler can tell us if we're not pattern matching on all the possible constructors. So like if we're handling a list and we only match on like the cons A case, then the compiler will be like, hey, you forgot to handle the empty list case. And that's one of the ways that this is a little easier to deal with than like an implicit null where the compiler can't tell you like, oh, hey, you missed this possibility. Okay, so everyone feel like pretty okay with data constructors? When we get more into the examples of what we're doing, it'll give more experience with like reading these and seeing what they're all about. So the next thing up on our list is value declarations. Now, value declarations is how we define like top-level constants and also how we define functions. Those are kind of the same thing in Haskell. And so in Haskell, to apply a function, you just use white space. So person A right here is a function. And it takes the string parameter, and it also takes this int parameter. And if we have a function, we just write the value we want to apply to the function next to the function, and that applies them in Haskell. So you don't have to do parentheses if you don't want to. You can also define type aliases if you want to. Type aliases are kind of a way to like make your functions a little more readable and give a little more intent to what you're talking about, but they're by no means necessary. So this double colon, we can read that as has the type. So we can read this value declaration for Goku as Goku has the type of person A, and Goku is equal to person A applied to Goku and 9001. That's all we know about his power level, I'm pretty sure. Okay. All right, so now for a function declaration, it looks very similar, but when we're talking about the type of it, we've got this arrow here. And that arrow is what's telling us that we're dealing with a function in Haskell. And we can read this function declaration as power up has the type a function from person A, and it returns a person A. The last thing on this arrow is the thing that it is returning. And the stuff that before that arrow is the parameter that it accepts. And so here what we're doing is we're pattern matching on the person A value that were passed in. And when we're pattern matching on that, that gives us the ability to like deconstruct that data and give names to the things that are inside of that data, which we can then use to reconstruct later in whatever answer we're giving. And so over here, what we're doing is we're taking that person A, and we're just reusing its name, and then we are adding 1 to its power level. So we have powered up the person that we passed into the function. Now, one thing to note is that this is an immutable function. We have a piece of data that we can't break down or destroy in any way. So what we're doing is we're constructing a whole new one, which is just modified in the way that we want it to be. So that's kind of the immutable paradigm that Haskell works in. And this is the same thing basically, but I've annotated it with these arrows and ASCII art. ASCII art is like my family. How do you feel about the pattern matching and mutability and kind of basic syntax for function declarations at this point? What's up?
So when you power up person A, you're getting a new person A, right? You're not changing everything.
Yeah, you're getting a new value of type person A that is the same as the old value, but it has itself powered up a little bit. Okay, cool. Move on a bit. So since Haskell is, right. So here's an exercise to get the name of a person. And I haven't written this yet. So who would like to provide the first thing that we should do to finish this function up? What's up?
Use pattern match on a person A.
Yeah.
Name and power. Guess just
Yep, that's exactly right. That's all we have to do to extract data out of stuff. So those were all functions that take a single argument. And functions that take a single argument are kind of boring. So we want to be able to take multiple arguments. And in Haskell, the way we write that is to just use multiple of these arrows, where for each, the last arrow is the return type of the function. And everything before that is the arguments that it takes. So this is a function that absorbs the power from one person into another person. And we're pattern matching on the value. And we're pattern matching on the other person value. And then we're returning a new person value, which has the 2 power levels added together. But there's a problem here. Like, because this is immutable, we've returned a new thing which is absorbed, but the old person still has all of their power. And we want to be able to express that we're like taking away power from another person. And so the way we do that in Haskell is we return like multiple things from the function. And so here, what we do, the way we can do that in a pretty lightweight way is to use a tuple. And this is just a 2-tuple or a pair that's of 2 person types. We've also got this new syntax for naming subexpressions in functions, and that's let. And so let is an expression where you have let and in. And then you have, between the let and the in, you have a bunch of declarations of like, this thing is equal to this other thing. And then after the in, all of those names that you defined in let are available in the expression there. So here we're able to say, okay, absorbed power is going to be equal to the person power level of that person plus the person power level of the victim. And the new person is going to be the person constructor applied to the person name of the person and the absorbed power term that we just defined above there in the let. And then the drain victim is the person with the person name of the victim and then a new power of 0. And then we just return the tuple of these 2. So how does everyone feel about the let syntax, the multiple arguments, all that stuff? Y'all look pretty bored, so.
This is admin, but I'm kind of getting
Yeah.
lost.
Yeah, absolutely.
It's that late, and I'm not going to try to catch up. It seems,
It is very like different and strange from what you're used to. There's like it's like the history of computer science all the way back to when it was like kind of invented in the 1930s. There's like Turing machines which start off over here and they go in that direction. And then there's the lambda calculus, which starts off pretty close, but then it goes in this direction. And Haskell's like way over here. And then the Turing machine stuff like C and Ruby is all over here. They're both about as weird as each other, but in different directions.
So regarding this, I would say that like a let in expression is kind of like everything you're defining in the let is just variables.
Yeah.
Which is, I think, like something that people must have. Everything that you define in that let block, it's basically just you're defining variables. So you can use them in.
Yeah, they're like local variables.
Yeah.
And they're only like visible after the in. So this top level variable is visible like in the entire module declaration. And if you import this module, everything defined in the top level is available. But the stuff in the let won't be available.
I have a question.
Yeah.
Can you explain in the function signature where you have multiple elements? Why
Yeah.
It seems kind of weird to me that it's like arrow, arrow.
Yeah.
Is it just like composition implied there or something?
Yes, there is. So one thing that you might see is that like right here, I don't actually have any partially applied functions right now, but this arrow syntax allows us to partially apply functions. And so if we provide just the first person, what this really returns is a function that takes a person and then returns that person drains it. So we can like we can partially apply this absorb power function and then say like, okay, we're going to make actually it's a cell. A cell has the type, it takes a person and then it returns a new pair of people, one of which is cell that has just absorbed all of your powers and is going to dominate your teammates. And the other is the victim that just got completely destroyed. So here, this is like a partial application to this function. And we could also write that as like, and it's the same thing. So that's kind of where the arrows are coming from. Does that make good sense to everyone?
It's a little confusing. That's like a really confusing part, I think, for everybody that's new. And
Yeah.
I don't necessarily need to understand exactly what's going on with that to understand the rest of what we're talking about.
Yeah, that's a great point. If you know that function is just like you use whitespace to, you just put all of your arguments like after your functions, that applies them. And if you know how to read like, this is a function that takes a bunch of arguments and then returns a pair, that's all you really need to know to get an understanding, at least just to get a working understanding, really. So also, if this stuff seems confusing or weird, it is, but it's not a whole lot weirder than the other stuff that we already are used to and know how to do. So it'll come. Yeah.
Are any of these actually using the function, or are these all defining what the function do? Like, are you applying, like, you know what I mean? Like, what would it look like if absorbs Vegeta's power? Like, how would you write that?
Okay, cool. So great question. Let's say we have a battle. So what we can do is we can say that we're going to supply 2 people into this, and we're going to use the absorb power 2 function on Goku and Vegeta, and we're going to get back the new Goku and the new Vegeta. And this is going to be like the first round of the battle. And then we can also say that unfortunately, this was not enough and Goku still loses to Cell. And that is the result of the battle. So when we apply this function over here, we can match on the value on the other side of the let expression. And then we can use that value we matched on and apply that to the cell function, which we get a result out of, and then we just return the result of that in the function.
You know,
On 238?
Just have a typo.
Good call, thank you. Okay, cool. Oh yeah, and this is another detail. The function's buying tighter than infix operators, so these two things are equivalent. This is another way to have named sub-expressions. You can use a where block. Where let is available like only after the end. Where is available in the entire like function declaration. So they're pretty much equivalent. You can use whatever you'd like. I put them here for reference. You don't have to like memorize all this stuff. Okay, so if we're gonna write another function that just takes a list and returns the very first item on the list, and we're gonna call that myHead. So we read this as myHead has the type. We take a list of A and we return the A that's at the front of it. So if we do this, what we do is we match on cons of A, and then if we have a cons of A, we just return that A. But there's a problem, is that like if we try to compile this, we're going to get this message from the compiler, and it's going to say pattern matches are non-exhaustive in an equation for myHead. We haven't matched the nil constructor. And so if we have a nil, there's no way we can get an A to return. So we have to just fail with a runtime error. And one thing that will actually really usually, yeah?
That syntax is going to be missing. The having two function declarations and like on two separate lines.
Right.
I don't think we talked about that.
We haven't. I'll get to that like right now.
Okay.
Right. So when we're pattern matching on a function, we can provide multiple definitions of that function if we're distinguishing the arguments in some way. So I can delete like this really temporarily. And we can see that the function myHead, we're giving it two definitions that match up with the two cases of the argument. So we have a cons A, and if that pattern doesn't match for whatever reason, it tries the next definition. We can kind of see another example of this with the safehead function. And so safehead won't ever fail at runtime. And we've got, what we do is we take a list, and then we use this case of expression to pattern match on the list and provide different branches to go through based on like what data constructor the list value is actually made out of. So this expression, case list of cons A, if we have a cons A inside of our list variable, then we'll return just the A that's inside of it. And if we have a nil in the list, we return a nothing. So there's another way we can write this function also. We can pattern match directly. And this kind of looks more like the original syntax. And these are completely equivalent. There's no actual difference between those two syntaxes. Okay, so how does everyone feel about pattern matching and defining functions?
Really dumb question. So what is the error syntax? Still don't quite understand. That's like a really cool thing.
Oh, that is, it's just a, are you talking about the arrow in the function signature or the arrow in the case matching? Okay, the arrow, it's just it just means it's a function. So,
like before it was like person arrow, then parentheses, and it takes two parameters. So there's like, is that like person type, and it takes two person operators.
Are you talking about this absorb power function?
Yeah.
Okay, so this is the last arrow. And so this thing right here is the return type of this function.
Okay, so
Yeah, so we're just saying that we're going to return two persons. And before that, we have a person that we're taking as an argument, and then another person that we're taking as a second argument. And then we're going to, when we supplied those two people, we can now return the pair of person and person. Good question, actually. Not dumb question at all about the use of the arrows in the case syntax. These are not the same as like the function arrows. They just mean like, they just are a way for the syntax to distinguish between the pattern that you're matching on this side and then the expression that you want it to be on the other side. So that's what's going on there. Does that like, make you feel more comfortable with it?
So it's kind of like the equals and when you do it the other way.
Yeah.
Like right above that, you have the equals and then the body of whatever piece you're matching on. But here it's just an arrow because that's how the syntax works. It's just the syntactic thing. Think of it as like you get a const A and then a list that you don't care about. Let's return that list A.
Why do you reckon they chose this syntax for pattern matching? It seems a little bit used for both. Regex //
Were they inspired by Erlang? This is like Erlang with the type constructors or type specifications inside the pattern matching.
And Haskell are both inspired by standard ML. And that's like kind of the syntax family this comes from. As for why they chose it, I don't know. I think a lot of people that, or especially a lot of the researchers that like invented and came up with standard ML and Haskell were really wanting to be like mathematicians more than computer scientists. And so they wanted it to look as much like they were doing algebra as possible. And it kind of looks like that. Like if I open up a like my discrete math textbook, it looks a little bit like my Haskell definitions, but yeah, that's correct. Yeah, exactly. You can these are just variable names, and it just binds the things to that. So it is pretty similar to like Prolog or Erlang pattern matching, but it's type directed rather than atom directed. If that makes any sense, if you're familiar with those languages, which I'm not. So you certainly don't have to be. Okay, and so this next thing, we're going to get a little tricky. We're going to get into higher order functions. And we can specify that this is an argument that we're taking. And that argument is a function from a type variable A to a type variable B. And given a list of A, we're going to return a list of B. And so we're just going to write the map function for lists. So for a concrete example, if we have like a list of integers, and we map over that with +1, we're going to get back a new list of integers with all of the numbers in that we have added 1 to it. So now if we have the empty list, then the only thing we can really do is return the empty list. If we have cons A and the rest of the list in A's, we can return cons B and B's. And we can get a value of B by applying the function f to the A. And we can get a value of B's by recursively applying my map with the f function to our A's value. So that's, yeah.
That's what is the, under my map note, what is the underscore?
Oh, yeah. The underscore just means we don't care about this thing, so we're not going to look at it. We're not going to like bother binding a variable name to it. All right. So everyone feel pretty okay on that? Okay, cool. This is how we'll use something like that. We can build a list using this constructor format, cons1 attached to cons2, attached to cons3, attached to nil. And then we can use the mymap function by passing this lambda to mymap as well as 1, 2, 3. And that just adds 1 to all of the elements in the list. So this is the lambda syntax for anonymous functions. We use the backslash to say, OK, we're starting a lambda. and then we provide the names of all of the arguments we want to use. And then we use the arrow to say, this is where the argument list ends, and this is where the expression begins. It's going to use these variables. And yeah, and this is equivalent in JavaScript to the syntax.
That's always in and nil.
You could have an infinite list. And Haskell is lazy, which, as am I, and I love it. So you can have an infinite list, and you can map over an infinite list, and Haskell handles that pretty all right. But yeah, if it doesn't end in nil, then it has to end in a cons. And if you just follow that, you can follow it into infinity if you'd like.
Wait, if you want to do 5, 6, it would have 5 brackets in it.
You could. This is a.
Is there a nicer syntax than that?
Yeah, there definitely is. So there is. This is like a custom list type that we've made up. The actual list type in Haskell has this syntax sugar for it. So you can just write 1, 2, 3, 4, 5, 6. And the data constructor, instead of being cons, is in infix. So it looks like that. You almost always will see like either this syntax, or occasionally you'll have like 1 attached to other 1, which is a list that's just infinite number of 1s going off the screen. If you want to be crazy, just really like the number 1.
That's the way it works.
Yeah. And since Haskell's really lazy, so laziness is kind of a weird topic that's hard to talk about. The gist is that to do. So if I have an infinite list of 1s and I say, okay, print the first 50 1s, please, it will run through that list and it will print off each one as it gets to it. But then when it's the 50th one, it's just like, okay, well, I don't need to worry about the rest of this, so I won't even bother evaluating it. Laziness is weird. Don't think you have to understand it. I don't, certainly. Okay. Cool, so this is infix operators. There are a lot of operators in Haskell. They're not special, really. You can define an operator with this syntax, and then you can use these operators however you would like to. We don't have to worry about this. Just know that it's there if you need it. And this is an implementation of filter, where we actually finally use if then else syntax, which is probably the first thing that y'all are familiar with. But you don't actually see if then else very often in Haskell, because there are other ways to kind of do that decision process. And so it just doesn't come up as much in Haskell code. There's guard syntax, which people tend to prefer. And yes.
Are these functionally equivalent to guard syntax and weird if then else?
Yes, they are. So with each guard clause, you have the pipe, and then you have an equals. And in between those two, you have some expression that evaluates to either true or false. And the first expression that evaluates to true, it uses that definition on the equals, and it doesn't try any other ones. And then otherwise, there's just an alias for true. Yeah. Yeah, the implementation of these two is the same. It's just a matter of taste, which syntax you prefer. The other thing that we see a lot in Haskell is the dot, and the dot is function composition. It's not object-oriented like property access. That can throw people off. Don't need to worry about it too much right now. The other thing that kind of can throw people off is they'll see a $, and a $, is just a function that says evaluate all the stuff on the right and then apply it to the function. And it's a way for people in Haskell to get away without writing so many parentheses all the time.
Question?
Yeah.
Do you have a question? I'm sorry.
Come
sorry.
up with a question right now.
Okay, so $. You'll see those a couple of times. The last thing that we kind of need to cover before we can get to the rest of the stuff is do syntax. Now, do syntax is actually going to probably seem like you're finally home. You see something you're familiar with. We're just laying out a series of statements that we want the compiler to execute. And so this is a hello world program in Haskell. We say that hello world has the type of IO, and the return type of this IO is unit, which is like void in C or Java. And the first, we use do, and this opens a do block. And the do block is basically, we give it a series of actions to perform, and it will do those for us. So the first thing is put strlen, or put string line, which prints a string with a new line attached to the end of it. And we just do 2 of these. And so if we were to run this in the REPL, we get it would just print out hello world so hard. If only it could print out an actual doggy, but I don't know how to print out a GIF in Haskell yet. So the next thing is that we've got these actions and we can do them, and then the IO will actually happen in the runtime. But we haven't talked about how to get stuff out of the runtime. And the way we do that is we use this backwards arrow. And so getLine has the type of an IO action that returns a string object. And when we call that in a do block, what it causes the compiler to do is it causes the computer to like block and wait for us to put in something. So it's like gets in Ruby or input in Python. And then when we can return that using the pure function. And so what we'll do is we'll take this, if we have like kind of the high level overview for like what the syntax means is we have on this side we have getLine. This has an IO of string. And then we bind out using the arrow the string. And so now this line variable, the line variable has the type string. And so we've bound the IO of string. The string inside now, for the rest of the expression, has the name line. And we can do whatever we want with it. What's up? Those are part of the prelude, which is something that's imported implicitly in every Haskell project. Prelude. It's just like a standard library. But because we're Haskellers, we like to be fancy.
So inside library, like, okay, so I'm just wondering if it's not highlighted, so it looks like it's not highlighted.
Oh,
I don't know. So,
I don't know the syntax highlighting. I don't know the rules behind it.
what is pure doing to that?
Pure is just a way to say that. So line is just of string.
Sure.
But what the function needs to be is an IO of string. A string, we can make it into an IO of string using the pure function. And pure works for a bunch of different types.
You're going to do that now, shouldn't say,
Yes, it infers that.
whatever.
Yeah.
In the signature, that's what pure is going for.
Yeah.
Gotcha.
So if we were to use pure line and the function signature said maybe of string, then it would return like just the string.
Right.
So
just line. Right?
yeah. Okay, so that's our do block. If we want to make a local variable in a do block that doesn't have the that's not like from an IO thing, we use let. We don't have to use in if we're in a do block with let. It's just available in the entire do block already. All right, and so that's all I've got on the syntax. Does anyone have any questions or anything they'd like clarity on?
What do I think about pure? I mean, can you think that honestly, asking at the end, like that you're just returning exactly what that function is expecting?
It's not quite a cast, because like if I had an int there and I did pure of like 5, it would give me a type error because int is not a string. Yeah, it's just a way to say like if you have like just a string that doesn't have anything else attached to it, you can make it an IO of string using pure. And you'll also see the function return used there, but some people kind of feel that that's a historical accident. But if you see pure, return and pure mean exactly the same thing in Haskell.
I think.
Yeah, return is not a keyword like it is in other languages.
But I thought you were saying earlier that our string up here is just as, is it already an IO string as soon as we do the get line?
Ah, okay. So get line is an IO of string.
It is an IO string.
Yeah.
Just the string. Okay.
So line here, this variable, this is just a regular string. It doesn't have any IO-ness attached to it. And so if we want to return that as the return value of this function, at the very end we use pure to make it into IO.
See, that's I guess what's confusing to me, because I mean I would think if pure and return are the same thing,
Mm-hmm.
return would return a string. Pure, because you said line is an actual string, right? Not
Yes.
an IO string. So return would return a string, but if you're doing pure line, you're getting an IO string.
Right. This is why people think it's an accident to call it return, because it confuses people for exactly that reason. Because in every other language, if you say like return 5, you return a value of type 5.
So when you say return and pure, the same thing, you mean return and pure, actually, but pure.
Yes, exactly.
That's like that.
Okay. Thank you for asking. That's a good question. Okay. Everyone else feel pretty okay with all this stuff? All right. If no one has any questions, for right now, if you have any questions, please feel free to ask me or Ben. But I'll turn it over to Ben now to go over the actual implementation of the website.
Okay, I don't need to be up on the podium right now, I guess. Does everybody have everything that they need installed? I can walk through kind of the process of getting it installed if anybody is not quite set up. But if everybody's run the instructions on the GitHub page, then we should be good to go. Okay, cool.
Cool. Give me a second.
So if you guys have everything installed, right? Can you open up the file myreddit.hs under the source folder? We're gonna work through implementing this thing together. And just to get us started off, I'm gonna actually show us what we're gonna be building here. There's a final file in there. I don't know if you guys have looked at it at all, but it's complete. And what we're gonna build looks like this. Go to Chrome, open up. Oh, like that. If we want to get the cats subreddit, we can get the cats subreddit, and gives us nice links and pictures for it all. If we want to we can also add multiple subreddits. And all of this is just going to be done in our URL right now, because it's simple. But maybe we want to mix in music or something, really like cats and music. And what it will do is it will get all of the current posts from either of those two subreddits and interleave them and display them for you. So it's not going to just show you all the cats ones or show you all the music ones. It's going to mix them together, which makes the implementation a little bit more interesting. And it's going to, say that again?
So what's the command to run this? Sorry.
To run this, you can, if you're in GHCI, which stack GHCI from your terminal, it should load all 4 of these modules down here. So you should have main, final Reddit, my Reddit, and syntax. If you just type final Reddit.server, it'll start up the server at localhost 8080.
What was the query and URL?
Oh, it's sorry, it's Reddit's equals and then a comma separated list of subreddit names. Is everybody familiar with Reddit? Guess I should ask that first. Sorry. I don't know how to fix that. The endpoint is /Reddit, and then there's a query parameter Reddit's equals, and then a comma separated list. That's what we're going to be building. It's going to fetch from Reddit concurrently, so that it doesn't take forever when we have a long list of subreddits.
What does the GHCI mean? What is
Okay. Yeah, I should start there.
Show that on your webcam.
Oh, I am?
Yeah.
Oops. Screen share. Yes. Yeah. So it stands for the Haskell compiler is called GHC, the Glasgow Haskell compiler. GHCI is the GHC interactive shell. So it's like Tinker, yeah, except it's much better than Tinker. Yeah, that's actually where I wanted to start, so that we can just kind of get an idea of how we're going to even run this thing. I mean, if you guys have this thing running, then you've already used GHCI a little bit. I'm going to scooch this over a bit. Whoops. I'm going to make this half. What? Sorry, one sec. Okay, that should be a little bit easier to see. First thing I want to talk about is just how GHCI works. We can load a module. Basically, all of your modules should be loaded, but you can specifically load. One thing actually we didn't touch on is you can specify the exports of a module in these little brackets here. And since we're only exporting one function, we can only run that one function from GHCI unless we specifically load it. So if you type :L and then my Reddit into, oh, whoops, I'm missing all my imports. One sec. Shoot, you guys are going to need these things. You take from the final Reddit top part, there's a bunch of import declarations. You guys can just take all those lines and copy them into the my Reddit. I messed up and forgot to put them there. You need them. To get started, you can, in your GHCI, you can just do :L and then my Reddit. And that will load all of the functions so that we can work through this together and piecemeal. Another thing that we can do is query like the type of a function or declaration. So you see this get Reddit here has type of string to IO of listing. We can do :T and then type the name of a function to get the name of a function. That's helpful if you don't know what the type of a function is. We also didn't talk about you don't need to provide the type. The Haskell compiler is smart enough to figure it out for you in most cases. So if you have a function that you want to write and you just write the body of the function, a lot of times it can figure that out, which is really nice and helpful. :T is also very useful for exploring third-party modules that you're importing. So there are functions that we're going to use that we don't necessarily know the type of, and this is helpful for kind of exploring what we're going to get out of them, or how to use them. Error here is just it's a placeholder that basically says we have to implement this thing, but it forces the program to compile anyway. So what we're going to do is we're just going to start working through defining each of these functions in turn, and at the end of it, we'll have something that does what you just saw, which is pretty cool. And yeah, I think that's like the overview of GHCI. Does anybody have any questions about how to use that? Oh, one last thing. :R will reload your module. So whenever you make a change, whenever you finish writing a function, just type :R and it'll reload everything into your. Is it? Sorry, I'm not at the top.
What branch are you on?
This should be master. What does yours look like?
Oh, I just pulled.
Does everybody's look weird?
It also has a fourth line that says empty data,
Oh, yeah, that you don't need that.
and it had all the ports to start.
It did have all the imports? Okay.
It's missing part 1, so
Underneath part 3.
where's what? Did part? It's not like part 1.
Was this here? All right, I actually just wiped that. I wiped out the imports and pulled them from the other file because I accidentally deleted them. Okay.
What's happening?
Does it look like this?
Yes.
Okay, that's fine. I just basically I accidentally deleted the imports on my local branch. And I was missing a bunch of them, so I just wrote those in there. But
So you have to do what you're doing?
no, you're good. If it looks like this, that's perfect. As long as if you can press, if you can do :L, what? Yeah, that's fine. You don't need it, but you can leave it there. It's okay. Yes.
So I missed something. How did you get into the REPL here?
Oh, okay. I'll back up. Just type stack GHCI inside of the root directory of the repository. Does that work? Okay. Is it installing stuff? Okay.
When I just ran this for the first time, it said that I didn't have a GHC and stuff like that.
Okay.
So I hadn't ran it in the stack setup.
Okay. Yeah, it might be a while. But it's all here, so if you want to just, you can watch and work through it. For now, you can ignore all the imports. We don't need them yet. I mean, you don't need to look at them. These are third-party libraries that we're pulling into the module because we're going to use functions from them. But you don't need to concern yourself with the actual lines themselves. So to get an idea of what we want to do, essentially, we have to get this Reddit data from somewhere. And a couple of ways to do that are, we could scrape the site, or we could use an API of some sort. There's actually a sort of third way of doing this, which is Reddit will give you a kind of API for a specific subreddit's page if you just tack on .json to the end. So I'm going to copy this and put it in the bigger text here. If you go to that, subreddit, it'll give you a listing of a bunch of, it'll give you the data about the listings in JSON format, which is much nicer than trying to parse through HTML. Is everybody familiar with JSON? Just want to make sure I'm not losing anybody. There's a Chrome plugin called JSON View.
Oh, what JSON?
Huh?
It's called JSON.
JSON View. And this just gives you, it says, this is a something of kind listing, and it's got a bunch of data associated with it. In particular, the children are the actual posts on that subreddit. So this has got information like the subreddit that it's in, gives you an ID, the author, it'll give you the score, and a URL to link to. Okay. How do we want to do this? So pizza's here. If you guys are hungry, go ahead and get food. If we want, I don't know, do you guys want to take a break and eat, and then we'll come back and just start this from here? Sound good? Okay, cool. I think it makes the most sense to just pause right here.
Demo is a thing that we're going to do. Calm your minds with food tasks.
What window manager are you using? That you get to
Window manager, it's called Divi.
Divi?
Yeah, it's an OS X thing. I don't know if it's, I mean, you have a Mac over there, but it's called Divi. D-I-V-V-Y. Yeah. I'm going to.
Just like screencast you eating pizza.
I'm gonna turn the camera on. had the sound turned off on the Hangout. So the next step is kind of to parse the JSON, because in Haskell, we want to be using kind of concrete data types that correspond to our systems and not just blobs of data, because there's a type safety that we have to kind of keep. And it's easier to work with data that's structured like that. So that's the next thing that we do. Getting something from that blob of JSON into this post or this listing data type is sort of non-trivial. It took me a minute. It digs into some slightly more complex things that I don't want to touch on in this workshop. So it's actually done. If you want to look at it, it's down at the bottom. There's a basically we can turn that JSON blob into a post and a listing. And I would encourage everybody to look at that afterwards, but I don't want to spend too much time just deriving that for you. But essentially, I've chosen a couple of things that we need to render a post on the front page of our website, or the Reddit URL. The sort of top level thing is a listing, and that's all of the whole collection of posts on that subreddit. And then each individual one is going to be a post. And this is that record syntax that Matt showed you earlier. We basically have a data type called post, and it has one constructor which takes these 6 parameters. Each of them is given a name. And these are text values. One thing that is interesting about Haskell, and sort of a historical mistake, another sort of historical mistake, is that the string type in Haskell is actually just a linked list of characters, which is not really very efficient for most applications. You want to be able to get a whole blob of text back. So there's a type called text. I imported it here. And I imported it as T because it has functions in there. It has functions in that module that clash with other function names. So when you see t.text, that's just text imported from the module called T. And specifically what we're going to get is the subreddit name, which we're calling subreddit. We're going to get the author, it's the author's name, the score, so how many upvotes versus downvotes it's had, a URL for that given post, a title of the actual thing, and a thumbnail image, which is just going to be represented as another text value. And we're going to derive show, which will let us take these things and print them out to the console, basically. And then the listing is the full thing, and it's just it has a single constructor called listing, and it has posts involved, and that's just a list of posts. So that's the syntax that Matt briefly touched on. This is just shorthand for a list of posts. Does that make sense to everybody? Okay. So the first thing that we probably want to do is, and this is where everybody gets involved. If you have a computer, if you've got this loaded up, you can write this out with me. We need to actually get the listing from a given subreddit. So I don't know, somebody give me a subreddit that we could look up. Smash Bros. Okay. So let's say we want to get all the listings from the Smash Bros. Well, we're going to write a function that actually gets them from anywhere. And then we'll look up Smash Bros. Later. So the first thing that we need is an actual URL to go to. And conveniently, this is the one that we want. And so we can use a let binding. And we can just call this URL and give it https www. So this open bracket, close bracket is concatenation. And that's what we'll use to concatenate that subreddit in. So we're taking the subreddit as an argument, so we're just going to concat it in there. And we can sort by hot. Hot, I guess, is popularity on Reddit, and .json. So that's the URL we want to get. Huh? Concatenation. Yep. We're going to use a module called a simple HTTP to do this. We're just going to make an API call to this URL. And that's going to look like this. Simple HTTP. And it's we're going to make a GET request to it. So it's the function is GET request, and it just takes a single parameter, which is a string for our URL. And since we're doing some network communication here, we have the simple HTTP function is going to return an IO action, which is going to contain our response. So we have to use this left arrow, which we talked about earlier, to actually extract the data from that response. The next thing we need to do is get the body. And this, to me, I think that this function makes more sense as like a pure function to just get the body from a HTTP response. But the implementers of this library have something else going on. So a good question would be like, why isn't this line a let here? But it just isn't. Just bear with me. But we can use a function get response body and just call that on the response. And that'll get us the actual content, just that JSON blob. And then the last thing that we need to do is, if we look at, I think it's network. So if we look at the return type of get response body, we are going to get back a we're going to get back a response. We're going to get back an IO of response. And what we need to do is we actually need to parse that body. And when we parse that body, we can get one of two things. So we can either have a successful result where we parse it into the data type that we're trying to parse it into, or if it's missing something, say it's like a completely unrelated data type, they returned HTML and that, or it's missing some fields in the JSON data structure. We need to know that it failed, and we need to know. So there's a data type in Haskell that encodes this, and it's called either. And what an either value is, it's either one thing or another. And so in this case, it's going to be either the successful data, the listing that we're looking for, or it's going to be a string that explains what failed. And we can get one of those from this body by trying to decode the body, and if it fails, then we handle that case. And I'll write this out so that it doesn't, so it's a little bit less abstract. But we're gonna have a case expression, and we need to use a function called either decode. And we're gonna call one more function on this body, which is CS, and I'll explain that in a second. My tab key. So if we get a write value out of this, then it's going to be the listing that we're looking for. And in this case, we'll just wrap it back up in IO. We'll just return that listing with the pure function that we talked about. And then the other case is if there's an error. Then we have a left function, or I'm sorry, a left type, and it's going to have a string associated with it. And in that case, we're just gonna error out. So if something goes wrong, our program's going to crash. And I just noticed we're missing one thing here. This all needs to be in a do block. So you can read this as kind of some steps. And the error takes a value. And so that'll spit out an error if it fails. So the CS that I glossed over, that's it's a function that just takes a string-like type and converts it to a different string-like type. So this either decode function takes a certain type of string, and body is not that type of string. But CS is just a way to kind of convert between the string types because there are a few of them in Haskell. So it's just a sort of convenience so that we can kind of move from one type to another.
So is that what's going on with the right and left? Is right's referring to body and left is referring to the other string that we made in it, or no?
What's happening is we're calling a function either decode here. Either decode produces either a write of a real listing, so that this data structure right here, it's either going to give us one of those, or it's going to give us a left with an error attached, which is just a string that describes the error.
Yeah, so, I mean, I understand it's either going to give us the listing, which we want,
okay,
or it's going to give us something else. So what are right and left? Like, where are those coming
from? Okay. So right is a data type defined like this.
Okay. They're coming from either?
Yeah. So it's going to be left A or right B.
Okay.
And yeah,
it's just part of it, really.
Yes. Yes. Yeah. Good question. Thank you. So we can load up my Reddit, and we can actually run this on Smash Bros. We can get the Smash Bros. Data. So if you type in get Reddit Smash Bros. HTTPS not supported. Oops. Get HTTP. All right, there we go. This is just a big blob of data from the Smash Bros. Subreddit. We can see we got back a post which has the subreddit Smash Bros, the author, the DARB, a score of 1549, and a URL and everything. How do you call the function? Like that. Just type the name of the function, space. Sorry. Oh, you don't need.
When we stack GHCI, don't we get final Reddit speed?
Say it again.
I feel like my GHCI is getting final Reddit as well, not just one my Reddit.
Oh, okay. If everybody could do this, type :L, and then my Reddit.
And that's all it's going to be.
Yeah.
Okay.
That work? Did you do the :L thing? Prelude not in scope? I think Matt's coming to help you. Here, I'll help you, Matt. Oh, you need you better write it. You're passing it. You have to use. So from here you can actually go. Okay, does everybody have a blob of text that's running that? Okay. Cool. You don't have to use in with let when you're in a do block. So yeah. So from now on, if you've got if you did :l my Reddit, you can just run :r to reload the module for the next time.
Question. So the let applies to the URL.
Yes. Yeah, that's correct.
The response and body, they're using that. So that's
The,
the case statement. Oh yeah, we also saw that for retrieving. So that's what that's.
That's correct. Yeah. So when you're retrieving something from the command line, it's doing I/O. Here we're doing it from HTTP. Yep. So the next thing that we want to do is we want to get. Let me move that. We want to get a list of Reddits. So we want to be able to pass in a comma-separated list of the subreddits that we like, and get an interleaved version of all of those things. And so to do that, we're gonna take a list of strings, which are going to be our subreddits, and we're going to return an IO of a listing, and that listing is going to contain the posts from all of the subreddits we pass in. And in order to do that, we need to have a listing for each subreddit. So if we want to get data back, we want to get posts back from Smash Bros and Cats, and we want to interleave those, we need to be able to take those two listings and merge them together. Make multiple requests. Yeah. I don't know if it does. like this.
Oh, just if you get subreddit and you post two subreddits with plus.
That works. We're not gonna do it that way. That's cool though. I didn't know that. So if you do, yeah, we're gonna do it a different way just because it illuminates some stuff. But yeah, we're gonna get multiple listings, and we're gonna, I guess like, we want to be able to control the way that they're merged together. But yeah. But we are gonna make those requests concurrently, so we don't have to worry too much about like the overhead of the time overhead, I guess. So to do that, we're going to get multiple listings, and then we're going to merge them all into one. So that's what we're going to do with merge listings. But we want to do it in such a way that they show up, all of them don't show up, like all of the ones from Smash Bros don't show up before all of the ones at Cats. So we'll implement that function. It's kind of a fun function to implement. And the last thing that we're going to do is we're going to write a function that prints out. It's a very simple function, but it's just going to print out the listing that we get from calling all of these subreddits. The first thing I want to do actually is merge listings, which is going to take a list of the listings that we get back from Reddit and merge them all together. And to do that, we're going to need, we've got our one. We have our listings, and what we want to do is, actually wish I had a whiteboard here because this is really an interesting idea. But effectively, yeah, it's not, it's sort of off to the side though. Yeah. What we're gonna have is, imagine that we're getting information from 3 subreddits, and each of them have 3 listings each. We're going to get a list of posts. So I'm going to call the posts from the first subreddit A1, A2, and A3. And similarly for the other ones, I'll do B1, B2, B3 for subreddit 2, and C1, C2, and C3 for the last one. And we want to turn this into basically, if we have these in a list, it's going to look something like this. If you comma separate them, we're going to have A1, A2, A3, then B1, B2, B3, then C1, C2, C3. If we just concatenated those 3 listings of posts. But we're going to have this. Effectively what the list of posts is going to look like. Does that make sense? And that's all going to be wrapped up in one big list as well. Does that make sense? Okay. So what we want is something that looks like A1, B1, C1, and then A2, B2, C2, and A3, B3, C3. Okay, yeah. Okay, I mean, yeah, technically what we want is remove these here. Yeah, thank you. That's the list that we want to get. And if you squint at this and you look at if you look at this right way, you'll realize that this sort of occurs if you just flip over this axis. Maybe you'll take C1, move it here, C2, move it here, B2, move it here. Same that way. Conveniently, there's a function that does that in the Haskell standard library. So we sort of get that for free. And then the last thing that we need to do, as Mark mentioned, is is merge them together. So that's the function that we're going to write. So what we're going to need is a new listing, because we're returning a listing. And then we're going to need a new list of posts. So I'll call this new posts. If you recall, that's how we construct a listing with a list of posts. So, and so we've got this function, transpose, which is exactly that function that I just described. It takes a list of A's and returns a new list of A's, but with them flipped over that axis. So we need to get the posts from all of the listings first. So write this in a where block. You can write where and then just press enter. I'm going to say all posts, and this is just going to be map posts over the listings. So we talked about extracting data from like the person constructor in the intro. We're doing the same thing. We're just extracting the posts from the listings. So this is going to give us a list of lists of posts. And then we can call transpose on that. Yeah. Will give us basically this, but with the inner functions. And then there's also a function called concat, which, ignore the foldable thing. This T can just be an extra set of brackets. Imagine that this is just has an extra set of brackets on it. It basically collapses a list from a list of lists into a list, which is exactly what we want to do. So what we're going to do is just all posts equals concat, concatenate the transposition of mapping the posts to listings.
So in this language, the parentheses are important.
The parentheses are, what do you mean?
Yeah, I mean, you have to wrap that transpose.
Yes, like it would. You would definitely confuse the language if you did this, because it would think that transpose is the first argument to concat, and that's not what we want. We want the whole thing to be the first argument to concat. Yes, sort of. I don't want to get into it too much, but basically, you can concat and transpose are functions, just like any mathematical function that you've used in high school algebra or whatever. Dot is function composition, so you can use dot to construct a composite function that first does the transposition and then concatenates. But I'm not going to define it like that because it's a little bit more confusing. Yes?
What is the order of operations? It's going to concatenate the lists and then transpose them?
It goes from right to left.
Okay.
So first we're going to map posts over listings to get the arrays. Then we're going to transpose, and then we're going to concat. Yeah, you tend to sort of read from right to left a lot.
Is it like that, or is it the order of that?
It is.
Yeah, it's not inside out. So since map post listing is in was like the innermost set of parentheses, I guess first, and then
Yeah.
as a result of that to transpose, and he has the result of transposing that to map. So that's how you
Okay, any other questions about this? Cool. So that's the function. That does what we want it to do. It'll interleave all of the posts as long as we have multiple listings.
Did we just change that to new posts from all posts?
Oh yeah, I'm sorry. I changed it from all posts to new posts. So the next thing that we're going to do is actually get a bunch of listings from just HTTP. It'd be kind of a pain in the butt to construct these manually, so we'll just grab them from Reddit. And then we'll test it out. This is going to return an IO action that returns a listing. And there's a really neat function called map concurrently in Haskell. And what this does is the same map idea. We're going to map a function over a list, but we're going to do all of the IO actions concurrently and then collect the results. And so that's what we'll do. And we've already got a function that we can use to do this, which is get Reddit. So this is we're gonna map concurrently get Reddit. We're gonna map get Reddit over the Reddits that we've defined. Does that make sense? It's the same as map, except we're gonna do it in IO, and we're gonna do it all concurrently.
Now in Haskell, you could put the parentheses around get Reddit.
Actually, no. So get Reddit actually takes here. The type of get Reddit is a string to IO listing, but Reddit's is a list. Yeah. So we have to map get Reddit over Reddit's. And then what we're going to do is basically we've got that list of listings, and we've got a function that merges them. So we'll wrap it up in IO and merge listings on the listings that we just got. That make sense? Now we can reload everything in GHCI, and if we do get Reddit's, somebody give me another subreddit that they like. Zelda? Gets us everything that we need. Let's see. So the first one is Zelda. The first post is from Zelda, as we can see, and the second post is from Smash Bros, which is exactly what we want. And it's kind of hard to parse this big blob of text, but it's going to interleave them as much as it can until one of them runs out.
What's the correct error? If you type like a type one that is not an actual subreddit, it says exception end of input.
Yeah. I think so.
Okay.
Did get Reddit work?
Yeah, it works if I type it.
Yeah. So we're cheating a little bit because when there's nothing there, up here, this error ERR. This is the branch that you're hitting.
Yeah.
It's just gonna freak out and not work.
Cool.
Yeah. Right now we're not handling everything.
Where did the map link the JSON to the objects? I mean, I see the data post. Right?
Yeah, it's.
How does it map the JSON to those fields?
So it's right here. The function is either decode, and it's just taking that body and turning it into the actual type. The type isn't annotated right here, but it's annotated here. And the Haskell compiler knows that you're looking for a listing. So the either decode is, the function is specialized to that, and it'll give you back the listing. It knows that that's what you want.
Or were you asking for title and title?
Yeah,
That's at the bottom.
Oh yeah, that's at the
It's
bottom.
It's on the listing. Maybe you didn't go over that because
from JSON post. Yeah, that's what
Yeah. This is the mapping. We don't need to define print Reddits because basically we're doing it right here. Essentially, do this, so we don't need that. We can, if everybody can run get Reddits on list containing Zelda and Smash Bros, then we should be good. Cool. Everybody good? Cool. Isn't it? Yeah. I mean, one of the reasons I chose this idea is because like the way that Haskell handles concurrency is insane. It's really amazing. And yeah, that's one of the things that is kind of fascinating to me as well. So. All right, so the last thing that we really need to do is actually turn this into a web page. I assume that everybody's sort of familiar with running a server, what it means to like run a Rails application or something like that, a dynamic web page. If you're not, raise your hands. Okay, cool. So we're going to use a framework. We're going to quote unquote use a framework. It's a very, very slim framework. Or I mean, we're using it for a very tiny little thing. We're going to serve a single web page or a single web page. But the framework is called Spock, and we're going to just basically use it for routing, and we'll throw this action in there. So the next couple of lines are probably just going to look like magic, and that's fine. You can find them in a tutorial, and you can dig into it deeper if you so desire. But reading there are a couple of things in here that are just going to look weird, and that's okay. We're just going to, most of it should look familiar, but some of it might be a little bit strange. Don't worry about it, it's not that complicated. So the first thing that we're going to do is we're going to run an application on port 8080. And to do that, we use the function called run Spock and get it the port 8080. And then we're going to use this function Spock T, capital T, ID. What I mean, don't worry about that. And then we'll use another $sign there. So that's the line that basically starts the server for you. And then we're going to have a do block. You can do this. A do block is just an expression, so you can put them wherever what you're using would normally require one. So it's totally valid to just put a do block in the middle of something as long as that's what it's expecting. A do block, it's going to have a type. If it matches up, then it's all good. We need one route, and it's going to be a get route as Reddits. And so that's just a get /Reddit on our web server. And then we're going to use another $sign just to say go on to the next thing. And this is going to be the declaration of what. So we want to accept a list of, we want to accept a comma-separated list of subreddit names under the query parameter Reddits. So we can extract from the query, we can extract a query parameter using the param function. I am, yeah, thank you. Let's forget the do. And so when you extract a query parameter from a URL, there's a chance that it's not going to be there. But we talked about this. There's no null in Haskell, so we have to handle it with a maybe type. So what param is going to give you back is a maybe of a string, which is the parameter. So we need to deconstruct it. We'll use a case expression. And so if there's nothing, this is where we're going to actually talk about what we want to return in this request. So if there's nothing there, let's just give back some text that says no Reddits provided. That means, you know, our user didn't provide any Reddits to us, so we don't know what to do.
Text is part of the Spock.
Huh?
Spock is not part of the dev.
Yes, yeah, text is part of Spock. That's a good question.
It's HTML. It's like servers over Spock.
Yeah, it's a function that turns a string into a response that's just text. And we'll use this little prime symbol here to differentiate between this Reddits and this one. So this is just saying if it's just a list of Reddits, then we'll do something else. And again, we're going to need another do block here. We can use a function called split on to extract. Remember, we're going to be getting something like, what did we have? Smash, Rose, and Zelda. So we need to split that into a list of strings for it to make more sense, pretty much. So we can use a function called split on to do that. So we're going to use a let here. And we'll say let Reddit list equals, and we'll use a function called split on. And we'll split on comma and Reddits. With the, don't forget the prime symbol here, or it will complain. That's gonna, if you look at the type of split on, Q there for now, but it says, you know, if you have a list of A's, and it's if you have a list of A's and another list of A's, it's going to give you a list of lists of A's, which doesn't really look like what we're doing. Like it doesn't look at all like what we're doing. But if you remember, I said that string is a list of characters. So this is actually a string, and it's splitting it into a list of strings in this case. But what it can do is, like, say you have a bunch of numbers and in some weird sequence, and you want to split it into chunks based on where like 2 and 3 coincide. It'll do that for you too. That's just a more general way of doing this. But in this case, yeah, you can read it more like string, string, string. So now we have a Reddit list, and we can use our new function, get Reddits, on the Reddit list. That'll give us back the listing that we want, merged together and everything. Somewhat magical function that we're going to have to use a sort of magical function here, something that I don't want to dig too deep into, but I'll explain it in a second. So this is going to be a listing, and we're going to get the Reddits from the Reddit list. One thing is, so Spock, the web framework, operates under its own context. It says I can do all kinds of things, not necessarily just I/O, and it lets you define like the types of things that you want to be able to do. You can extend it and everything. So just like we have to annotate I/O, we have to annotate things like the modification of state in a program, or there's just a slew of things that we can annotate. And when we're operating under a certain context, sometimes we have to move from one context to another. Or specifically, we want to go from a context that only knows about I/O to something that knows about I/O and state. Sometimes that's what we want to do. This is very abstract, but just bear with me. So Spock knows how to do all kinds of things, and it even lets you define your own stuff. But we just want to do a simple I/O action, and so we're operating under the context of I/O. But if we try to just call get Reddits here, it won't type check because this is operating in one context, and the whole Spock block is operating in a different one. So they're just incompatible. And so there's a function that lets us take an I/O action and something else that knows about more than just I/O and just move it from the I/O context into the larger context, and that's called lift I/O. So we just need to wrap this whole thing in lift I/O, and that'll let us do what we need to do. And don't worry if that doesn't make a whole lot of sense, because it's a very abstract thing, and it's something that you just have to spend time with before really getting acquainted with it. But it's kind of just a magical function that lets you do that. Is there a way that you would describe that?
I think that's a pretty good job without getting into like monad transformers.
Okay, cool. Yeah, I don't want to talk about monad transformers. All right, so now we've got our listing that we want, and we know how to transform the listing into a string. So before we get into actually displaying HTML and everything, because we just want to see something up on the screen, let's just spit back a text with the listing. But to do this, we need to show the listing. So that'll convert it into a string. But text actually wants a text value. So we'll use that CS function that we talked about earlier to just convert it from a string to the text that it expects. So now, if you reload your module and then just type server, you should be able to load up localhost 8080/Reddit ? And then Reddit's equals in the comma separated list of the subreddits that you want to look up, and press enter and get a 404. That's exactly, yeah, that's it. Thank you. All right. So we didn't have that route. Here we go. All right, so yeah, you get this big old blob of text that you saw in your terminal a minute ago. It's now showing up on the web. It's pretty cool. Yes? Yeah. Yeah. Yes. Yep. There are more specific ways to do it, but this is a library that basically just abstracts all of them. So you can kind of do it without worrying about it. Cool. Okay, so now we've got the text showing. But really what we want is like a nice format for this stuff. So we need to define some views. Is everybody familiar with Bootstrap? At least what it is. So we'll use Bootstrap to just throw together a nice listing here. And the first thing that we need to do is get Bootstrap from a CDN and serve that into HTML. So Bootstrap CDN. There we go. So the type of all these things is going to be we're using a library called Lucid, which do all of these functions that let you write out HTML, and it'll turn it into actual HTML using a couple of different functions. And the main HTML actually has a type parameter. We're not going to use it, so it's just unit in all these cases. It's pronounced unit. It's going to be an HTML thing, but it doesn't have any. It's not going to do any. It's not going to do anything other than like provide the structure. So you could potentially give. You could say like the HTML builder can connect to a database or hit the network or something to get the HTML that it wants. But I would like to keep the HTML building as pure as possible, so we can just provide it the data it needs and it can build it from there. But that's what that is. But the HTML type is just it's just a way to, it's like an HTML builder essentially. So the first thing that we want to do is like actually get the bootstrap. So we have to pull the script from somewhere, so we're just going to pull it from the CDN. And Lucid has a bunch of functions that are just basically the names of the HTML tags, but with an underscore after them. So this would be like link, and then we can provide any parameters to the link that we want in a list of parameters. So we want to give it an href, and with an underscore, and then the whoops. No. We need this. That's going to bleed off the screen a little bit because my screen's a little big. Line, put a comma, so tagging something else onto the end of the list, and then rel is style sheet. Anybody know what rel means? Because I don't. Relationship? That sounds right. That sounds right. And so that's our bootstrap thing. We can shove it in the header. So the next thing that we want to do is be able to actually view a listing, but this actually sort of, here, I'm gonna leave this like that for now. So viewing a listing is probably the last thing that we want to do because it's going to be the full view of the page. It might make sense to define functions that can render various parts of the posts and the posts themselves before we define that, so that we can define view listing in terms of render post, render thumbnail, and this one. So this is going to be Bootstrap specific. It's just going to do like a column with a medium width screen, and we'll be able to give it an integer. So you can say like, I want a two width column. So let's do this one first. If you haven't used Bootstrap, this might like not look like much, but it's just basically we just need to provide some classes to a div, and we can reuse this function to give us what we want. So we need a div, and it's going to have a class of, in Bootstrap you use call md. And then I think, yeah, that's right. So call md dash and then the width that you want. So we might want like a 3-width thing. We're providing it an int, and in Haskell you can't just concatenate a string and an int together. So you have to convert it. And on top of that, the HTML builder expects this thing not to be a string. It expects it to be like a text. So we have to use that CS thing again. But we can use show on the span. It'll be the span of the column. And then we just need to CS that. Get a text out. I believe that's correct. So
Why is
it's
the class? Sorry, why is the
That's the Lucid builder. So Lucid is building the div and then just giving it a class of column D and concatenating on whatever columns we want. So you can put in, you know, I want it to span 4 columns. But that div underscore and class underscore are Lucid, right?
yes, these div and class are functions that Lucid defines, and essentially it's building up this HTML structure, and then eventually you'll call a function on it to turn it into actual HTML. We can do that. So I think I have, there's a function called render text that should be loaded automatically if you're in the my Reddit thing. We can render text, and this was called call MD. Oh, the other thing. Okay, so this function signature maybe it's confusing people, because it takes an int and then another HTML element. The other HTML element is the children of this div. So they'll be provided as a third argument. And that's just something that Lucid knows how to do. It's a little bit magical. But so that's the children. And we can render text, call, oh, whoops. To, so say we want a 2-column, and then we'll just give it a div with nothing in it. That gives us like the HTML that we're looking for. I put the div, which is what we want. So the next thing that we'll do is we'll render a thumbnail. This will render a thumbnail image on the side of the Reddit post if one exists. Sometimes they don't exist, so we're gonna have to do a little bit of plumbing here to make sure that we're only rendering the ones that actually exist. We don't get a bunch of broken link images. So we have a source that's going to be the URL for the thumbnail, and what we want to do is we want to make sure that the basically the way that I determine if it's a link. So just from my exploration when I was building out this thing, is there are a bunch of links to things like self and other words that I think mean something to Reddit but not to us. So what we need to do is we need to strip those out and not treat them as URLs. So the best way that I found to do that was whenever there's a thumbnail, if it starts with HTTP or HTTPS, then we'll consider that to be an image. And that has worked 100% of the time so far. So what we want to do is we want to break the source into 2 things separated by the : / that you typically see in a URL. So if you have something like self and you split it on : // you're just going to get you're not going to get anything before the : //. It's not going to. There's no HTTP or HTTPS there. So we want to look for HTTP or HTTPS before the : // What we're going to do is we're going to use a function called break_on, provided by data.text. So prefix it with T, and we're going to break that URL on : //. And I think it's useful to see this. So what break_on does is it takes a blob of text and a body, another blob of text, and it turns it into everything before the first argument and everything after it. So we'll get HTTP or HTTPS if it's a URL, if it's a valid URL. So what we want to do is we want to split this into cases. And the type that we're working with is there's a tuple of text and text. So this is interesting, sort of. So basically, if we see HTTP as the first part before the : //, then it's a URL. And if we see HTTPS as the first part of the URL, then it's also a URL. You can use the underscore to match any other cases. So this will match everything that doesn't match those first two. And we'll do something different in that case. That's basically the logic of it. Yeah.
Should we be calling break_on on SRC? Or is it?
Yes. Yes. Good catch. So yeah, you have to provide the argument. So now we actually have to return like an HTML thing, and it's just going to be a matter of building this stuff together. So we'll let the image column, this will kind of float to the left of everything. And we'll use this column MD function that we just defined. We'll just give it a width of 1 because it's just a thumbnail. And then we'll use image, and the source of the image will be the source that we passed in. And we'll make the width 80 pixels. So if we actually find an image, then we'll just use that. We'll use image column in both of these cases. Just so you know, there is shorthand for this type of thing. You can definitely reduce duplication here, but I thought this was probably the simplest way to define this function without like adding a whole bunch of extra logic in there. And so if there's no image, then we'll just render an empty column. And we'll just give it a div that you have to give it an empty string just to say that the body is nothing. So that's the thumbnail. And we can, so let's say our thumbnail is self. You guys don't mind putting that worked right. If you want to do this, what I'm doing right now, you can type that line out, and it'll allow you to do, render thumbnail. I'm sorry. So when you render the thumbnail itself, it should just give you the column, the bootstrap column with an empty div inside of it. But if you give it an actual URL, or what it thinks is an actual URL, google.com, it'll try to link google.com as an image here. Which is fine in our case because we're only ever going to be passing it in a thumbnail from Reddit. So the next thing that we need to do is actually render the rest of the post. And we'll use some deconstructing here. So here we'll deconstruct the post. These are just the fields that we have defined above. And we can use them to build an HTML thing. So the first thing that we'll do is start a do block. I guess one thing that I haven't mentioned is that do blocks work with HTML. I think so far we've only seen them with IO, but they work with HTML as well. It's structured in such a way that you can write like sequential blocks of HTML, and they'll just append in the HTML document that results when you run render text against it. So that's exactly what we're going to do here. And this is just going to be like a format that I found that looked pretty good. So it's really just going to be a bunch of typing of the same kind of stuff. But we're going to use a bootstrap row, and row is defined. It's part of Lucid. It'll give you a class, a div with the class row. And inside that row, we want to render the thumbnail of the post, which we're getting from here. And the next thing that we want to do in this row, this will be the title row. We'll do a medium column that spans 8 columns. And we're going to reference the URL of the post. So we'll put the title and give it a link. And we can call toHTML on the title to turn it into an HTML block that Lucid understands. That'll be the first row. And then underneath it, we're going to display all the metadata, like the score and the author, and things like that. So the first thing that I want to do is I want another medium column that kind of offsets the thumbnail. So we don't have all of the stuff displayed all the way to the left. You'll see what I mean in a minute. Basically, the thumbnail is going to be taking up a column on the left. We don't want to put things directly underneath it. We're going to shift that over one. We're going to shift the next line over one column as well so that it matches up with the title. Just put an empty column, medium column 1. And we'll just give that the children of an empty div. Oh, we actually need to wrap this. What? We actually need to wrap this in a second row. And then we'll do a 2-column thing that displays the score. So score. A little space there. And then we need to score is an integer, so we need to turn it into a string and then turn that string into HTML. Make sure that you put these little underscores after the fields, because score is a valid identifier that refers to a function. I just ran into an issue where I was complaining that it can't turn a function into a string because I was referencing the wrong thing. The next thing is just subreddit. Oop. Can't keep up. My editor can't keep up with me. And again, I did it. And the last thing is going to be the author. Last thing we need to do is take our listing and actually like render all of the posts in the listing. And this is a pretty simple function because we already have everything that we need to do it. We just have to dig into the posts and actually display it. So, so to view a listing, all we need to do is render each post and then concatenate them all into HTML. If that makes sense. So we're going to be producing a whole bunch of HTML open brackets, and if we do this, so we'll pull in listing posts, and if we map render post over the posts, we're going to get one of these because we're using map. But what we want is just a single HTML one of these. So to get that, we need to use a function called mconcat. What that will do is, if you remember the little bracket thing that we were talking about earlier to concatenate two strings together, this guy, this function works on more than just strings, and the HTML authors were smart enough to define it for HTML. So what this does is it just applies this to, in turn, it will basically collapse a list of things into a single thing using this operator wherever there's a comma. It's kind of how you can think of it.
There's something that you can add to your objects that says that it can use that. So it's like foldable, but it's concatenable or something.
Yes, exactly. Yep. It's called a monoid. Monoid. Yep. So yeah, so now we've got a way to view the listing, but we still need to pull in Bootstrap. So we're going to write one more function called render all. And render all is going to take a listing and return an HTML unit. And render all on a listing, we are going to, first we're going to render Bootstrap. And then we're going to view listing. Ah. So now we can kind of do the plumbing here and get back an actual thing, which hopefully will work for everybody. If you can do this in your REPL, did that work for everybody? Sweet. You guys followed along really well then. So the last thing that we need to do is just produce some HTML. So there's another function called HTML, which is a part of Lucid. And then we're going to need to do another little bit of string manipulation. And we're going to do render text. We're going to render everything to text, and then we're going to serve HTML. Render all listing. Why? So first we're gonna render the listing along with the bootstrap. We're gonna turn that into a text value. So just the raw blob. Then we're gonna convert it into a thing that that Spock understands with the CS. And then we're finally gonna use the HTML function to turn that blob of text into an actual response. And it's going to populate some headers that say, this is HTML, so your browser knows what to do with it. So if you :r and then type server, and then you go to localhost 8080/Reddit with we were doing Zelda and Smash Bros. And we get what we expect, basically. I think I missed one thing, which is at the end of render post, it's nice if we have like an HR that's just empty. I think, oh, actually this one happens to need a list of parameters. So if you add that, it makes it look a little bit nicer. We can reload and server again. There you go.
Can you
Yes.
go back to that last change that you made?
Yes, yeah. It was right at the end of render post. I added an HR. Yeah, and you need an empty list as the argument. Everybody get that? Does it work? I can't tell if it's working. Tell me yes or no.
It's good.
Okay,
Yeah.
good. Sweet. All right. Well, that's all I've got. You can click through these things. The URL, the links work, and everything. And yeah, that's it. There are some obvious extensions to this if you want to go home and keep playing with it. One is obviously just rendering more information. So maybe a comments link. You'll have to dig into the data declaration and modify it, and then change the parsing logic. That's a good exercise. And then fill it into the rendering process. Another thing you can do is write like a form for this. So you're not just having to type in the comma-separated value in the browser. Instead, you could turn it into a post request and take a form. What else do I have? I have a couple of suggestions. They're written down somewhere. So another thing that was pointed out was it freaks out if the subreddit doesn't exist. There are definitely ways to deal with that in Haskell. We just didn't have time to really dig into them. Akin to a try-catch in any other language. Adding exception handling that makes sense would be a good exercise. And kind of on like the really crazy side of things, implementing like OAuth for Reddit and actually logging into your account and getting your homepage and rendering that. It's also another really, it would be a cool extension to the project. So if you want to work on any of those things, or if you're intrigued by this this workshop and you just want to go home and keep working on it, messing with it, those are some things that you might want to try.
Where's a good place to find like Haskell libraries? Like if we wanted to do OAuth, I'm sure somebody's got.
Yeah, there's the main place is Hackage. That's where all of them are hosted and published by various people. There's also there are a couple of links that I added on the GitHub site that it's just introductory things, and there's one more post that I'll probably add to it, which might be what Matt's thinking of.
There's a website called HaskellIsEasy.com.
Oh, okay.
That goes over like what the people actually use for like building applications. I put a ton of libraries to solve like common problems. So
They also do, I've heard there's like a search engine or maybe it's plugin for your editor. So if you know the type of signature, it helps you find.
And yeah, you can just like search for a type signature, and it will search all of the packages that are on that page, and it will say, hey, here are packages that have type signature. And since Haskell type signature is actually very often is the case that does exactly.
Yep. I actually didn't know about Haskell is easy.com. I was going to recommend, there's a blog post called The State of the Haskell Ecosystem by a guy named Gabriel Gonzalez. And that is a really good kind of overview of the things that Haskell is good at, bad at, and just what it's doing and recommended libraries for each domain. I don't know. Did you want to wrap up with some of the other things that we talked about? I know you wanted to talk about a couple of things. Okay, I'll let you take over from here then. Thank you, guys. Any questions? I don't think I asked. Okay.
Okay, so if you're intrigued by all this Haskell stuff and you'd like to learn more about it, the first thing that I would recommend is if you can afford it, this is a really, really fantastic book for learning Haskell. It's, I think, about 1,200 pages. So like it is $60, but it's also 1,200 pages of like really good explanations that can take you from like knowing absolutely nothing about functional programming at all to being like able to work as a Haskell developer professionally if you wanted to. So I would really highly recommend this book if you would like to go forward with that. There's also a repository on GitHub by the same person, and that's here we are. That's github.com/bitemyapp/learnhaskell, and this repository has just a whole bunch of like ways that you can get into learning Haskell through like a curated list of like free online courses, blog posts, and other things like that that can kind of get you from being introductory level to advanced level. Like this CS240 course is really good. It goes into like advanced stuff like modi transform, how the runtime actually works, like how laziness actually works. All that stuff is really, really good for getting, what is, oh, I never understand maxing the command key. So this is the Haskell is Easy website. It kind of goes into like the things that Haskell can be used for and the ways that like professional Haskell developers will solve the problems. And just like the very basic, like this is how people solve the things. You don't have to look through like Hackage, which has maybe a dozen packages for solving something. This is the canonical one to actually do the thing. So if you're wondering, like, okay, so the things that Haskell is really good for right now in the thing is for building like APIs and web applications like we're just built, where you just need to put up like a pretty a high performance, not super, well, you know, as complicated as you want endpoint for processing JSON, for receiving that, really easily converting that into something that your application can model it, and then processing it and then handing it back. So that's one really good thing. Another really good thing that you can do is a library called Turtle, also by Gabriel Gonzalez, and it's all about shell programming. Something in Bash, and all of a sudden the performance of your Bash script started to be a problem. And this actually happened at my work. We had a Bash script that was running. It would pull a whole bunch of routers, download the stuff, parse the information, and then do stuff with it. We translated that from Bash script to Turtle script, and it was almost a one-to-one changeover. But the big difference is we use map concurrently instead of map in one instance, and that like pretty much multiplied the speed of what we were doing by about 16. So that's nice. Also, writing Bash is awful, and if you can do it in almost any other language, it's much better. And this gets you types. Another neat thing that Haskell has is quick check. And quick check is property testing. And what that means is that you can describe abstractly that like this function that I wrote has some properties. So like if you give me a certain kind of input, the output should look like this. And what quick check will do is it will generate about 100 tests. it'll try to catch every edge case that it can relating to that property. And if it finds an edge case, it'll shrink that edge case down and say, hey, your function doesn't act like you think it does, and here is a minimum example in order to demonstrate that error case. And you can also call Haskell from anything. So you can use quick check, and you can use the Haskell functions that you write in whatever languages that you want to use. And right now, it looks like it's supporting Python, Ruby, C, JavaScript, C#, Java, etc. So you don't have to, like, if you want to start incorporating Haskell into your stuff, you don't have to, like, build this giant monolithic application that does everything. You can start incorporating very small parts of it. So you can start writing, like, a bash script that just takes a bash script that you have and then write it in Haskell to get a little more type safety or a little more performance out of it. Or you can write some quick check tests that test your existing code to make sure that it actually has the properties that you want it to have, and that there aren't any edge cases that you didn't think of when you were doing your example tests. And you can also do really good benchmarking. Like if you have some code that's running too slow and you need to make it faster, you can use the Haskell library criterion to benchmark code in any language to identify, like, okay, this is how it's running now, and then I make these changes, and this is how much faster it is. And it will rerun the code a whole bunch of times and generate a lot of statistics about how it's actually working. So you can know if you've got a lot of, like, environment stuff messing with your numbers and your stats. So yeah, lots of stuff you can do with Haskell that's, like, very real and useful. There's also a lot of theoretical stuff that's really fun, but that's only fun if you already know what it's doing. But yeah, does anyone have any questions about that kind of whirlwind tour of things you might want to do after?
This is just a silly question. It's, Smalltalk has, I can't even remember what it is. There's a way to say, hey, this is what I start with, and this is what I end with. How do I get there? And it just, like, magically does it. This has one.
Oh, that's a pretty common way of designing software in Haskell. Is you'll say, like, okay, well, I have, like, some end type that I want my thing to be, and then I have my input type that I know what it is. And then you can just, like, use a type-directed programming to just break that single function with one arrow into a bunch of functions with a whole bunch of arrows. And then you, like, have a better idea of, like, what types you're looking for as you're building the thing. And then you can use Hoogle to actually, yeah, let me bring up Hoogle. I know. Hoogle is pretty cool. So, like, if we're looking for something that takes a string and returns a text, then we can do that, and it'll search everything, and it'll find all of the functions that have that type signature. So if we say that we have, like, a function that takes an A and returns an IO of B, and we're looking for something that takes a list of A.
So this is doing it for type signatures. Can you actually put real data into there and have it give you what you're looking for, the function you're looking for?
Oh, do you mean like an example of the data? And then, oh, that's actually really cool.
Yeah.
I don't know offhand what that would look like.
Like, you're able to say, hey, I'm using these types. And
yeah, this is really nice. I use this all the time when I'm developing.
I don't know if anything like that. It sounds cool.
it's crazy. Yeah, I mean, you can literally, like, write out a long example, and then it'll show you exactly what you need to do to get there.
That's really cool.
Like, I want to start with this string, and I want to wind up with this string. You know, figure it out for you.
That would be really interesting to try and do.
Yeah.
Generally with Haskell, the way you, like, design a software program is you start with, like, the data types that you use, like, the data constructor to make, like, what my input looks like. You use the data to define, like, what my output looks like. And then you just, like, work case by case, like, how do I transform my inputs into my outputs? So,
I mean, in the future, we can maybe put together another conference or another meetup where we can design that.
Yeah, that would be really cool.
Design.
Yeah, definitely. That would be a lot of fun. I don't, like, have any plans, so I can probably hang out here and do a little bit of that afterwards if anyone wants to stick around. Okay, so.
Any questions? Anything else? What
you're choosing a functional language, let's say Haskell closure and other ones, what are the advantages of Haskell? Compared to the other ones. I mean, in general, it's pretty clear.
I think concurrency is a big one that we're kind of just starting to see.
Yeah.
Haskell's concurrency mechanisms are amazing.
Yeah.
So that's kind of a new feature that I want to use it for. I like having types to basically do exactly what Matt said. Take thing A, turn it into thing B, and basically as soon as I can make that happen, the program's done. So in that sense, it's a very different way of developing. I use PHP, and it feels different than using the dynamic language. But I mean, I don't know. It's more specific.
Yeah. So like the dominant functional languages that you can actually use are like Haskell, and then there's Scala and Clojure, and then F#. And Scala, Clojure, and F#, they're all nice languages, but they operate on either the JVM or the CLR, which are virtual machines that are optimized for like object-oriented languages and highly imperative languages. Whereas Haskell, the runtime for Haskell is optimized for a functional language. So it occurs that in Scala, you'll write like some highly functional code, and the performance will be 10 to 20 times worse than the imperative equivalent. And so you'll write some functional code, and it's really nice, and it's bug-free, but then you can't actually use it because it's too slow, so you have to convert it back. In Haskell, you do not pay that performance penalty. So that's, in my opinion, one big advantage of Haskell. And since it doesn't have to worry about like interop with Java or C#, the language design can be much more pure in that sense. Because like a lot of, like Scala has a ton of warts from like having to interop with Java types. And Haskell doesn't have to do any of that. So it doesn't have to worry about like any of that business. That said, if you need to write like a GUI app on Windows, Haskell is not a good choice. It's a terrible choice for that. Well, I've never programmed on Windows, but if I ever have to, F# is probably what I'll choose. Yeah, after that, like the things that really set Haskell apart from other functional languages is that it's purely functional. So like you can't have side effects generally. Like in Clojure, it's immutable, but anything can call print, or anything can call like access the database, or anything can call like launch the missiles or whatever. In Haskell, if something has like a type from A to B, you know it can't print, it can't get the database, it can't do anything aside from take an A value and return a B value. The other thing is that it's lazy, which is, I think, really cool. But it's so different that it's hard to like sell in a few minutes, other than you can just work with infinite data structures, no problem. And you can, so like if you wanted to write a chess engine, you could write a function that takes a chessboard and returns all the next possible chessboards. And then you could make a tree that started with the initial chessboard. And you could just say, okay, I'm going to unfold this tree and create the infinite tree of all possible chessboards. And you do that, and you hit enter in the REPL, and it just completes instantly. And like as soon as you start like exploring that tree, it starts generating it on demand. So the code for like, okay, give me all possible chessboards is just like easy to write on demand without taking up any more memory than you actually end up using. So I think that's really neat. But
I think it's really cool too. I think like, yeah, there have been debates over whether or not it's a good design feature, but I think it's really cool too. And you can turn anything strict.
yeah. All right. I'm done.
All right.
So
Thank you guys for coming.
Thanks for doing this. Great.
this was
So I noticed that you were in